So let me introduce myself first before even starting this session. So my name is Navdeep Kaur. I'm a technical professional with 13 years of industry experience. I have worked with different technologies like big data, DevOps, cloud computing, and in different MNCs. And then I started my own company called as TechnoAvengers.com, who is responsible for upskilling the corporates, professional with latest technologies. We have been working on many e-learning courses also. So I'm a author of many Udemy courses on big data with 50,000 students worldwide. So that was a brief about me. I think we should know your speaker first before we start with anything about this session. So what this session is about, so I'm very excited, guys. I'm very excited that I got a chance to talk about few of the technologies, few of the new things in the big data engineering world. Okay, so in this session, I am not focusing on any one technology. I will not be going in depth on any technology. I will be talking about more of the shifts and the evolvement that has been happening in the data engineering world. Okay, so I will be talking about the shifts, the new buzz keywords, and the what the future holds for the data engineering from my perspective, from the industry perspective. So we will be seeing that first. Okay, so since I would say before even starting my first slide, I would say like the last decade was from the data engineering perspective, the last whole decade was dedicated to data lakes, data warehouses, where our main focus was how to ingest data. Our main focus was how to capture data, how to process data, and also not even just process data, how to process different kinds of data coming with different velocity, how to deal with batch data, streaming data. So all of that was our main focus in the last whole decade, and all the technologies that you may have heard about was revolving about around them. Okay, so everything that was revolving around how to process it, how to do the distributed computing, everything was around it. Okay, but as we are advancing forward now, all those have is already, we are now our mature data engineers, like the industry has now mature data engineers. They know how to deal with data now. They already know the technologies that can do that, like Spark and all those. But now, this new decade, few things are shifting, few things are getting evolved, few approaches are getting changed. That is my main focus. Okay, so this new decade is focused to modern technologies like lake houses, like modern data stacks, like modern data warehouses, data mesh. Okay, so I'll be talking about that shift, like why this shift is happening and what was this new approach is all about. But before even going to those new buzz keywords, I'll talk about, like before I'll talk about what was a traditional approach that we were taking, right? So obviously you must have heard about warehouses. Like what were the traditional warehouses? Like whenever you want to deal with structured data, whenever you wanted to have some data that has to have some structure in place, and you wanted to derive some business insight about from that data using some analytics workloads, that is where we were using warehouses. So this is not a new technology, this is an old technology that we were using. Okay, we were extracting from different data sources, we were transforming the data before loading the data into the some warehouses where it could be used for further analytic workloads, right? So this was a kind of ETL approach that we have been doing since decades, and we have been using these data warehouses from such a long time. Okay, but these warehouses were not a perfect solutions because there were so many challenges that these warehouses bring us. First of all, obviously, we are talking about traditional warehouses. They were not meant for dealing with big data. Okay, they were not meant for handling large amount of data, because First, the reason was they were really expensive. The storage at that time was really expensive. The compute was expensive. So we cannot afford to have all the data in our data warehouses. So we have to do some upfront analysis. Okay, upfront transformations were required. We have to know how we are going to deal with the data that is going to get very precisely, like how we are going to dump into our data warehouses, what kind of SQL queries our business analysts are going to fire on that data. Okay, so all that upfront analysis, ad hoc experimentation, we have to do it before we go to fire on that data. Okay, so all that upfront analysis, ad hoc experimentation, there was a lot of development cost in terms of efforts, in terms of time, that you have to do even before doing the first analytic queries on top of your data that was there in your data warehouses. So that was the very challenging aspect of using that entire ETL approach, the extract, transform, and load approach, right? I'll talk about the new approach also in later slides. Okay, but this was the approach that we were using, right? And also, there were a lot of missed opportunities. When I say missed opportunities, since we were loading the data, and even before loading the data, we were cleaning the data, discarding and transforming the data. A lot of raw data was discarded, right? We were not keeping the data in the original formats. So there could be a possibility that that original data could be used further in the future for some business insights, but we were losing all of that data in those transformations pipelines. And there were a lot of missed opportunities, there were a lot of missed data that we could have used for further analysis, right? And more importantly, the last challenge that everybody, you must be knowing, I'm assuming that you are coming from the data world, so you know that it was not suitable for the unstructured kind of data, right? The data warehouses were meant for structured data. They cannot deal with the unstructured data, like your photos, your images, your semi-structured data like JSON, XMLs, all that were, there were a way of doing it, but it was not a perfect way of using data warehouses for such kind of data. Okay, so the first approach, like those warehouses, there were a lot of challenges that was happening. Okay, then the market starts moving towards a different era of cloud computing. Like cloud was there since 2006, but the acceptance of the cloud came later. Like the market, the industries, the startups, the big giants start moving towards the cloud at later years, like I would say from 2013, 2014, the acceptance was growing, right, for the cloud computing, right? The reason was very obvious. They were providing cheap storage. There were no like cheap compute was there. The networks were faster. They were also complying to a lot of industry standards. There were encryptions in place. There were securities in place. So a lot of things was introduced by cloud, and the cloud became more and more mature, and the industry starts moving towards cloud, right? And because of all these shift, okay, from costly storage to cheap storage, from costly compute to cheap compute, a lot of new things came into the market. Okay, the first of all that came was the a new architecture design that was called as a data lake. Okay, so in the data lake, instead of having moving the data just into the some data warehouse or into some database, or just use the data straight away for some machine learning or any other kind of workloads, we just extract the data in the raw format into some storage layer that is mostly the cloud storage layer. Like for AWS it is S3, for Google Cloud it is Google Cloud Storage, for Azure they have their own storage. So we started using their cheap storage, the cloud's cheap storage, to load our data in the raw format. So it was very fast. We don't have to do any upfront analysis to think about how the data should be used and what data should be discarded and how we should, our struggle to, save the storage cost, our struggle to save the compute, cost, all that struggle was gone with this cloud invention, right? With this cloud acceptance, I would say, not the invention. The cloud was still, it was there a long back, but with the acceptance of the cloud, all that struggle that data engineering were facing, that went away. We started using this data lake as a mediator layer in our architecture, where we can load raw data, we can clean and validate data when how and when it required. Okay, maybe not on the immediate basis. Whenever it is required, we can do that. We can build our data pipelines, later on whenever is required, and then we can just have those clean validated data loaded to some data warehouses, and also have those clean valid data plugged into some machine learning algorithm for modeling and predicting few stuff, and maybe for putting that data into some databases, maybe for any use cases you have in your mind, right? So that was the with the cloud acceptance, the data lakes architecture came into the picture, right? But this was also not perfect, right? The industry was moving towards it. It's still the ETL approach. We were extracting the data, we were transforming the data, we were loading the data. It is still an ETL approach, but it was not a perfect solution. The reason was there were a lot of challenges with this data lake that was not handled properly at that. I'm not talking about today. AWS S3, all those are coming with better solutions. They are still not perfect, but they are coming with better solution. I'm talking about the last decade. Okay, how the evolution was happening. Okay, so there were a lot of challenges with the data lakes, right? When I say data lakes, just think about the storage layer, about the AWS, like cloud providers that are cheaper, that we use to host our, raw data as well as our transformed data. So those data lakes were not ACID compliant. Okay, they don't provide transactional support. They don't have a consistency, right? And also security was a major limitation of data lakes. Okay, so you can have the data, they provide some kind of encryption in place, the data was secure while at rest or while in transit, that was there. Role based access was also there, like the people can, you can just define who can use what kind of, like what kind of storage, that was also there. But a lot of security aspects were missing, like the complete audit logs were not there, like who used, when used, and what was prohibited. All those audit loggings were not there, fully integrated with the data lakes. Also, there are other features, security aspects, since we were, pulling the data from lot of untrusted data sources as well as in the form of unstructured data. So there were a potential risk of cyber, malware in that entire pipelines. Okay, so data lakes were not as secure as we want them to be. They were not ACID compliant. If we wanted to have some updates on top of our data lakes, that was not possible. Okay, at that time. Okay, so transaction support was not there, and a lot of enterprise features like data governance, maybe data masking, complete data audit, as I already said, a lot of data governance features and lot of other aspects of data that we think in our platform, all of that was missing. Okay, so because of these challenges that I talked about in the data warehouse and the data lakes, it the market requires some unified platform. The market requires something that has best of both the worlds, and that is where a new keyword was introduced. I think it was introduced in 2021 by the Databricks company in a paper, okay, at I think Stanford University. I don't remember the exact paper in which it was published first, but The Databricks was the first company, and there was a lot of other companies has taken this buzz keyword that was a data lake house. That is the best of both the world. Okay, it is data lake plus data warehouse. Whatever is best of the both the world is what a data lake house is. Okay, so what is a data lake house? This is what is I was just telling you about the evolution just to introduce you, like what led to data lake houses, all those challenges that we were seeing. Okay, that is what has led to data lake house. So data lake house is a platform that requires to fits everything. Okay, it it is a platform that should be asset compliant. Okay, that should have a transaction layer in place, that should fit all kind of data, whether it's a structured data, unstructured data, semi-structured data. And this should be a platform that should be suitable for machine learning, analytics workload, all kind of workloads. Okay, nice, right? This is what we want, right? We want a platform that should have, that should focus on all the challenges that data lake was having. Not just that, it was having a lot of other challenges, like this like I would say data lakehouse not just fit everything, not just have a ACID compliant and the all those things that I have discussed in the last slide. It also give us with a lot of other data features that is the requirement of the market. So today this decade is not about data distributed computing or handling big data. This decade is more about, I would say, all these five things. It's all about having a unified platform that not just handle our big data, that can also handle data security, that can also handle data versioning, that can handle time traveling, right? If you have changed some data, you want to go back in time, or maybe you have changed some data, you wanted to use some previous versions of data to run different kind of workload. That is also the necessity of the time, right? We also schema enforcement, right? To have the schema not just on the structured data but also on top of unstructured data, that is also the requirement of the day. Okay, data governance, since I said a data lake house is meant for all kind of workload, whether it's a machine learning, whether it's an analytics workload. So we want some kind of unified metadata layer, what to say, unified catalog layer on top of our data, so that we can have a single layer on top of it and we can view it in a unified manner. Okay, so we need that catalog layer in picture. We need the data governance, a more easier way to govern all the required regulatories and regulations that is required with our data at one place. And also we need our data to be, data integrity to be in the picture. So all these came with the data lake house. Okay, so the data lake house is a platform, a unified platform that fits every data, that has all the ACID compliance in place, that has all these data aspects in place. Okay, and the first company, obviously that's what I said initially, the first company that bring its own entire lakehouse platform, the enterprise edition for that, is the Databricks company. Okay, though AWS also provide a way to build a lakehouse architecture, but it's not that simple because it requires a lot of other services to be integrated and coupled together. I'll talk about that later. But Databricks is the first enterprise solution for the lakehouses that was that was meant for everything that we have discussed in the last few slides. Okay, so it is not like it has its own storage layer. It is still based on the traditional data lakes, right? It is still, the Databricks company is still based on the AWS cloud, Azure, Google cloud. It's still based on the same uh, data lakes, right? But what it has changed, it has introduced a lot of layers on top of it. The first layer is a delta lake. Like what the delta lake is, So it's a storage layer of Databricks. That is a, you can say the Databricks is the company that introduced this Delta Lake storage layer on top of this, cloud storages. And this Delta Lake provides a way uh, to update the underlying data that was missing in the data lake. In the pure data lake, there was no way to update the data. We cannot update the data in normal S3 or Google Cloud. So Delta Lake was made a top layer in order to provide an updation layer on top of data. Not just that, it also provides a performance layer on top of data, because it also works with the metadata about the data that was stored at this layer. Okay, so Delta Lake came up with lot of compaction techniques. The Delta Lake came up with the updation technique, the transaction support, whatever the asset compliance was missing in the data lakes. That is what the Delta Lake layer came with. Okay, so that was the first layer that this Databricks introduced in their Lakehouse architecture. And after that, not just that, in order to provide all that data security, data governance, data auditing, all that features that we wanted from our unified platform, that is the demand of the market today. That was also introduced by the Databricks in the Unity catalog layer. Okay, so this is the layer where they keep all the metadata. They also keep this layer is also meant for the governance purposes. They have the unified view of all the tables, all the underlying machine learning models. So whatever, like what was underlying it. So this particular layer keeps, is meant for handling all the data security, data governance, all those aspects that we have discussed in the last slide. Okay, so I'm not promoting this platform. It's still, data lake houses is still a new concept. It's not a very, I would not say it's matured yet. Okay, but obviously Databricks is still the leader in the lake house concept as far as the market goes. A lot of other players are also, fighting and getting their own places. Let's see who will win the race, but this is one of the platform I think industry is accepting at a very larger scale. Okay, the one more I would say architecture that I would like to show you, I will not go into this detail of this architecture, is the AWS Amazon cloud also provides its own lakehouse architecture. So it's not very simple, as the Databricks is an enterprise edition and you have a unified platform using which you can do everything at one place. But in the AWS, it provides a way to build your lake houses using various different services like Athena, Glue, EMR, SageMaker, a lot of different services, Redshift Spectrum. Okay, all these services has to be integrated as a one service, as a lakehouse architecture. So there is a way to build lakehouse architecture in AWS, but I would say it is difficult. Yeah, it is difficult. It's not unified yet. The way we are looking at from the market perspective, we want simplified products where we can just focus on more on the business part rather than on the technology part. So it's not yet there. Okay, so I just added this slide just to let you know that yeah, there are other people who are also going towards that lake houses concept, but it's still not there. Okay, so the question is, are we ready for this lake houses? Like I already told you what was the requirement, what we were looking, what was the focus of this decade. Okay, so are we ready for these lake houses? I would say partially. Okay, because as I said, only one Databricks is the only one that has a fully unified platform built for the lake houses. There are other platforms also that have few features of the lake houses, but they are not matured yet. Okay, I would not say the market is matured yet to handle all the aspect that we are expecting from a complete unified lakehouse platform. Okay, but yeah, or eventually you may be like the right direction in the future is obviously to have a lake house rather than having separate warehouses, separate data lakes, and then to handle all those challenges. It's always have to have a better solutions in your tech stack, right? So this was first evolution that I talked about was from data warehouses to data lakes to lake houses. Now the question arises, maybe you may be thinking like, okay, I don't need a data lakes. I don't want to deal with unstructured data. I'm just happy person. I'm just wanting to deal with the structured data. And I need a better data warehouse. I don't want to deal with traditional data warehouse. I just want a better data warehouse. Do we have a solution for that? Okay, so the question is, do we have a solution for a better data warehouse? Okay, so I think the time is limited. Alex, you just have to remind me, okay, when I can stop the session, because I can just keep on going, for a while. So I just wanted to talk about the better data warehouses. Okay, not just data lakes and the data lake houses concepts have evolved. Even with the cloud, a modern cloud data warehouses has also came into the market. Okay, so I would say, if you have heard about the name, I'm sure you may have heard about Snowflake, Databricks. Okay, even that Databricks comes in the modern data warehouse. Azure Synapse Analytics. Okay, Google BigQuery. Okay, all these Amazon Redshift. All these are the example of modern data warehouses. Okay, what is special in these data warehouses, like there is no limitation to storage. Okay, it uses the same uh, cloud storage that are cheaper. Okay, it uses the same cloud compute instances that are cheaper. So you don't have the liability that I have shown you in the first slide, like with the traditional data warehouses there was a liability, like the compute was expensive, the storage was expensive. With the usage of the same cloud provider in the data warehouses as well, those all limitations are now gone. So if your company is only working with the unstructured data, sorry, the structured data, okay, and you don't want to go for the unstructured, that is not your requirement, and you don't want to go for the data lakes or the lake houses, you can still go for the modern cloud data warehouses, where there is separate cloud storage, there is a separate compute layer, there is a separate metadata layer, a lot of optimized features are there, a lot of enterprise features are there, time traveling is there. I would say the list is limitless. Like the modern cloud data warehouse comes with a lot of so modern feature that the traditional data warehouse doesn't have, right? So, and also not just that, okay, not just that, it also came up with a new approach. The new approach was not to not to have ETL. Okay, so I told you, like we have to, in the traditional warehouse we have to extract, transform, and then load the data. But with this cloud data warehouse, the industry has moved to a new approach that is called as ELT approach. Okay, where we can still extract the data from different data sources, but now we don't need to transform the data upfront. We can simply load the data in raw format into our cloud data warehouses, because now storage is not a concern. Now your compute is not a concern, because we are using cloud everywhere. Okay, so this ETL approach has now been shifted to the ELT approach in your cloud data warehouses. Okay, so once you have loaded the data in the raw format in your data warehouses, you're not missing on any data that may get lost during the transformations. Okay, you are having the data in the raw format, so you when what and when required, you can transform the data, okay, accordingly, and build your analytics workloads in your data warehouses. Okay, so this is a new approach, ELT approach, that came with this advent of these cloud data warehouses. I just have few more slides to go. I hope you're enjoying it. So this is the another, I would say, moving from traditional data warehouses to cloud data warehouses, and moving from ETL approach to ELT approach is a new shift. that I have been seeing a lot in the market, right? People are moving towards, these new data warehouses. Not just that, with these new data warehouses, a lot of new tools have been, flooded into industry. A lot of new tool for ingestions, like I would say just few name a few, like Five Trends, Stitch, Airbyte, that was just meant for loading the data into in these modern data warehouses. They have been flooded into the market. Okay, so I already said all these names, like the data warehouses that we were focusing right now: the Snowflake, BigQuery, Databricks, right? Azure Snaps by Microsoft Cloud, Amazon Redshift. Okay, so we load the data directly into data warehouses, and then we transform the data. Either it could be transformed using the Spark, or it could be transformed using a new transformations tool that is like DBT. Okay, this is a newest transformation tool that is being adopted by, the data warehouses world a lot, because it is mostly based on SQL queries only. Okay, so even the business analysts who don't know about programming, they can also go and create their own data pipeline without the use of data engineers at all. Okay, so there is a, shifting of entire like even with this entire modern data stack, even the people who know SQL, they can just go and build their own data pipelines. Okay, so this was few trends that I have talked about, few technology shift, few, and few other shifts that has happened over the time. Okay, I will not be covering, one more thing I had in my slides, but I think the time is not there. I just wanted to talk about one last thing, like one more trend that may happen in the future. It is not happening right now, is moving towards data mesh. Okay, so it is a new trend that may or may not happen, because it's just like, moving toward more modularized approach, where data is being taken as a product rather to have a centralized database or data lake or lake house, and then you process the data. The data has been decentralized on different domains, right? And rather than a ingest and the push model, it has been now may get changed to serve and the pull model, and it may be owned by different teams. So it sounds very, unrealistic at the moment, like how it can be done, like why we want to decentralize, and who will be, owning that entire data. That will be a complete mess. It sounds unrealistic, but as even the microservices was unrealistic at, few years back, but it was realized later on, and a lot of technologies came up to make that microservices, modular microservices, a reality. So maybe the data mesh may be a reality in the near future, right? So I would say just go over the internet, see what the data mesh is all about. Maybe it might interest you, right? So I think uh, my time has already been passed. So that was all about that I would like to discuss today, the shifts and the trends. I hope you like it. And if you would like to connect with me, you can connect with me on LinkedIn. My on Navdeep Kaur, you can search for it. You will find me out. It's very rare name to find out. Okay. So thank you, everyone. Thank you, everyone, for joining this conference. I really appreciate that. And thank you, Alex, for organizing it.